So today we will talk about the bounds of trigonometric functions. Specifically, mag-prove tayo ng mga theorems on the bounds ng ating sine and cosine. So we will use the sine and cosine kasi 'di ba dito naman usually in-express yung anim na trigonometric functions natin. So throughout this video, gagamitin natin itong c of x to denote the cosine function and s of x to denote the sine function. So pag nakita nyo yung c of x, ibig sabihin nun cosine x. Yung s of x naman is the sine x. At para i-prove yung mga bounds ng sine and cosine, kailangan natin itong corollary na ito. Okay? So sinasabi dito that the function c and s satisfies the Pythagorean identity. The square of c of x plus the square of s of x is equal to 1. Now let's prove. So first, we let f of x be equal to the square of c of x plus the square of s of x for all x na element ng ating set of real numbers. Now, if we take the derivative of f of x, okay, so we have f prime of x is equal to, using the power rule, we have, di ba, ibababa lang natin ito, 2, bababa, 2, and then cosine x minus 1, kaya ito. And then, by chain rule, kailangan natin kunin yung derivative nito. Ano bang derivative niyan? Diba? Derivative of cosine x is equal to negative sine x plus c. So, kaya, meron tayong i-multiply na negative s of x by chain rule. And then, plus, again, kunin natin yung derivative nito. We have, babalang natin yung 2. So, we have 2 times s of x minus 1 kasi yan. And then, yung derivative ng s of x. Ano ba yung derivative niya? Diba that is just cosine x plus c. Kaya meron tayong c of x dyan. And then, by some algebraic manipulation, we have negative 2 c of x s of x plus 2 c of x s of x, which is just equal to 0 for x element of the set of real numbers. So, what does this tell us? Kasi yung derivative natin is 0. And we know that kapag yung isang function, ang derivative niya ay 0, this means that the function is a constant. So this implies that f of x is actually a constant for all x element of the set of real numbers. Now, the question is, anong constant to? Diba? Kasi lahat naman ng constant, 0 ang derivative. So note that f of 0 is equal to c of 0 squared plus s of 0 squared. Ano nga ba yung c of 0? Di ba yan lang ay 1? So we have 1 squared plus, ano yung s of 0? Di ba yan lang ay 0? So we have 0 squared. So we have now 1 squared plus 0 squared is equal to 1 plus 0, which is actually equal to 1. So, specifically, yung constant pala na yun is actually equal to 1. Therefore, we conclude that f of x is equal to the square of c of x plus s of x squared is equal to 1. So, that proves our corollary 1. So, we will use this to prove the bounds of some sine and cosine. So, ito na yung theorem na gusto natin ngayon. Okay? Theorem 2 states that if x is an element of the set of real numbers where x is greater than or equal to 0, then first, s of x is greater than or equal to negative x but less than or equal to x. Second, c of x is greater than or equal to 1 minus 1 half x squared but less than or equal to 1. Third, s of x is greater than or equal to x minus 1 over 6 x cubed but less than or equal to x. And finally, c of x is greater than or equal to 1 minus 1 half x squared but less than or equal to 1 minus 1 half x squared plus 1 over 24 x raised to 4. Now, we will show you the proof of this theorem. Let's start with the first. So, proof of Theorem 2a. Corollary 1 implies that C of t is greater than or equal to negative 1 but less than or equal to 1 for t na element ng set of real numbers. Okay, balikan lang natin yung ating corollary 1, no? So, ito yung kanyang sinasabi. So, bakit ini-imply nito na C of t is greater than or equal to negative 1 but less than or equal to 1? So, pag pinansin nyo ito, observe that, di ba ito dapat ang sum nila ay 1. So, yung mga possibilities dyan is, para pinaka-maximum niya, di ba, is 1 ito, tapos 0 ito. Tama? Para maging 1 siya. Kaya yun yung upper bound niya. Ang pinaka parang minimum, parang ganun naman, is negative 1 yung C of x natin. Kasi pag in-square natin yun, magiging 1 din lang. Plus, tapos 0 ito, kaya magiging 1. So, kaya naging ganito siya. Yung bounds niya ay negative 1 hanggang 1. By integrating the inequality for x greater than or equal to 0, okay, integrate lang natin to from x to 0. So, we will have the integral of ct dt from 0 to x is greater than or equal to the integral of negative dt from 0 to x but less than or equal to the integral of dt from 0 to x. Okay, check natin ngayon isa-isa. Ano ba itong integral na ito? Okay, ano ba itong integral na to? We have the integral of negative dt from 0 to x is equal to negative t evaluated from 0 to x. So, ano ba yon? Yun lang ay negative x minus 0. Diba? Ipasok lang natin yung dalawang limits or that is equal to negative x. So, the integral of this is negative x. How about the second one? Anong integral nito? So, the integral of cosine t dt is equal to sine of t evaluated from 0 to x. Or that is just s of x minus s of 0. Ano ba yung s of 0 natin? Di ba 0 lang yun? Kaya s of x siya. And finally, ano naman yung integral nito? That is just equal to x minus 0 or that is x. And therefore, napalabas na natin yung gusto natin for Theorem 2a. Now, moving on to Theorem 2b, gagamitin naman natin ngayon yung result natin from 2a. Okay? So, if we integrate the result in Theorem 2a for x greater than or equal to 0, balikan lang natin, no? Ito yung result natin for 2a. So, we have this integral. So, the integral of s of t dt from 0 to x is greater than or equal to the integral of negative t dt from 0 to x but less than or equal to the integral of t dt from 0 to x. Now, tignan natin, anong ba itong mga individual integrals na ito? So, first, the integral of negative t dt is actually equal to negative 1/2 t squared evaluated from 0 to x. So, ipasok lang natin yung 0 and x na bounds. So, we have negative 1/2 x squared minus negative 1/2 times 0 squared. Or that is just equal to negative 1/2 x squared. For the second integral, we have the integral of sine of t dt that is just equal to negative of cosine t evaluated from 0 to x. So, we have negative c of x minus negative of c of 0. But what is negative c of 0? Diba that is equal to negative 1 kasi c of 0 is 1. Okay? So, we have negative c of x plus 1. And finally, eto naman, ang kanyang integral naman is 1/2 t squared evaluated from 0 to x. So, that is just equal to 1/2 x squared minus 0 or that is 1/2 x squared. Okay. And then, pansinin ninyo, kailangan c of x lang ang maiwan dito sa part na to eh. So, anong gagawin natin? Kailangan tanggalin natin yung mga kasama niya by first subtract natin yung 1 sa lahat. Okay? So, by subtracting 1 to the inequality, we have negative c of x is greater than or equal to negative 1/2 x squared minus 1, but less than or equal to 1/2 x squared minus 1. And then next is, kailangan c of x lang to, so we by negative 1. So that becomes now c of x is less than or equal to. Note that nag-reverse na yung ating inequality. Kasi 'di ba, meron tayong theorem na kapag nagmo-multiply or divide ng negative, kailangang mag-reverse yung ating inequality. So here we now have c of x is less than or equal to 1/2 x squared plus 1, but greater than or equal to negative 1/2 x squared plus 1. Or in standard form, that is just equal to c of x is greater than or equal to 1 minus 1/2 x squared, but less than or equal to 1 plus 1/2 x squared. Observe that dito sa part na to, more than 1 na siya. Eh di ba sabi natin kanina, ang cosine x, ang bound lang niya is from negative 1 to 1. So actually, pwede nating sabihin na hanggang 1 lang yan. And that is c of x is greater than or equal to 1 minus 1/2 x squared, but less than or equal to 1, which proves our theorem 2b. Now, moving on to the proof of 2c, ganun ulit, we integrate the result naman nung theorem 2b natin. So, parang chain lang to, no? Paulit-ulit. Ginagamit natin yung mga previous results. So, balikan lang natin yung result ng theorem 2b. Okay, so we have here. At yan ang gagamitin natin para i-prove yung theorem 2c. So, we integrate this now. We have the integral of ct dt from 0 to x is greater than or equal to the integral of the quantity 1 minus 1/2 t squared dt from 0 to x, but less than or equal to the integral of dt from 0 to x. So, tignan ulit natin yung mga individual na integrals. So, the integral of this is equal to, we have t minus 1 over 6 t cubed evaluated from 0 to x, or that is just equal to x minus 1 over 6 x cubed. And then, the next naman, integral is we have integral of c of t from 0 to x dt is equal to s of t lang yan, evaluated from 0 to x. So, we have s of x minus s of 0, but s of 0 is equal to 0. Therefore, we have s of x. And finally, integral of dt from 0 to x is just equal to x. And that proves our theorem 2c. Now we are down to the last theorem, theorem 2d. Again, gagamitin natin yung result from 2c. So by integrating the result in theorem 2c for x greater than or equal to 0, balikan lang natin, ito yung result ng 2c natin. So we have the integral of st dt from 0 to x is greater than or equal to the integral of the quantity t minus 1 over 6 t cubed dt from 0 to x, but less than or equal to the integral of t dt from 0 to x. So ano nga ba yung integral ng first natin? So this is just 1/2 t squared minus 1 over 24 t raised to 4 evaluated from 0 to x, or that is just equal to 1/2 x squared minus 1 over 24 x raised to 4. So the second integral naman, we have the integral of s of t is equal to negative c of t evaluated from 0 to x. So we have negative c of x minus negative c of 0. But what is c of 0? 1. So we have negative 1, or we now have negative c of x plus 1. And finally, we have the integral of t dt is just equal to 1/2 x squared. So, since c of x lang ang gusto natin, tanggalin natin yung mga kasama niya by subtracting negative 1 to the inequality. So, we now have negative c of x is greater than or equal to 1 half x squared minus 1 over 24 x raised to 4 minus 1, okay, but less than or equal to 1 half x squared minus 1. And then, by multiplying negative 1, we have now c of x is, okay, nag-reverse ulit kasi negative 1 yung multiply natin. C of x now is less than or equal to negative 1 half x squared plus 1 over 24 x raised to 4 plus 1, but greater than or equal to negative 1 half x squared plus 1. In its standard form, that is just equal to c of x is greater than or equal to 1 minus 1 half x squared, but less than or equal to 1 minus 1 half x squared plus 1 over 24x raised to 4, which proves our theorem.